Hmm. Okay, folks, good afternoon. We'll go ahead and get started. So, yeah, what I'd like to do for today to start us off is talk about, if you had any time to take a look at those questions on the last part of our last discussion. Can I find these here? Do I have them? Is this it? Yeah, somewhere here. Okay. Oh. Okay, there we go. Yeah, so I wanted you to take a look at this big mushy concept that in the social sciences, people have several stabs at trying to define this thing, political orientation, and how one would do it over and above, like, are you a Republican, are you a Democrat, are you independent, or, et cetera. Those very basic nominal categories. There are other ways that one could go about doing this. So think about different indicators or dimensions of those terms are kind of fuzzy in themselves, why they're different, but different measures overall, okay, of this thing called political orientation. We need something more than just knowing what party someone voted for in the last election too, because Democrats are not all the same, Republicans are not all the same in their views towards issue X, right? So, and then I've asked you to operationalize that. That is when you're getting much more specific with, okay, exactly how would we measure this in a quantitative way so we could put it in SPSS and do some analyses on it. So the kind of units of analysis, at what level would you be collecting information from individual people, from this percent of people that voted towards the Democrat Party, Republican Party, or however in a particular county or whatever, levels of measurement, so if it's going to be just like a yes, no response or something that's more levels to it, like Likert item or something like that. And this exhaustiveness attribute, this where you want to try to take into account everything that possibly could indicate someone's political orientation, and not leave anything out that would be really important to know in terms of really identifying correctly who is very liberal versus conservative, however you want to define it. And then that you have measures that are exclusive from one another. That is, that they don't they're not really the repeated same thing, saying something the same way, just slightly differently, or they're measuring something different. Like each of your items are measuring political orientation, but they're doing so in a way that's different enough from one another that they're not just, it's not just being redundant. That's the exclusiveness kind of concept there. Okay, so yeah, that was what I would like you to have thought about. And you know what? Before I guess I go back to you guys on this, I want to just quickly point to some stuff that I posted on Moodle here just recently that deals with this subject of how one's political orientation could be measured, could be defined. So there is a group of researchers headed up by Jonathan Haidt, among others, who have found out that what determines people's political affiliation, and really to a large degree how they identify politically, whether they're liberal or conservative, is very dependent on how they construct their morality in these finite number of ways. So it turns out that there's only so many ways in which people feel strongly morally towards certain issues. And what these researchers found out, looking at the little graph here, is that people can basically, in the whole world, can be divided up into these 5 different pillars of morality. How concerned about not doing harm they are, how concerned about fairness and equity, that kind of thing, how concerned about that they are, how concerned they are about loyalty to one's group, to one's country, one's religion, how much that they respect authority, the importance of authority, and then purity. This is the one that is concerned with purity in diet, purity in sexuality, purity in a lot of things that deal roughly with health or with sometimes with cultural traditions. So that's this other pillar, morality. And turns out that this does a pretty good job in identifying how people are politically. What it's showing is that people who are very liberal will rank really highly on things like being very concerned about not doing harm and being fair and equal to everybody. They're very highly ranked on that, and compared to how much liberals rank on these other items down here that are indicating morality. So in-group favoritism, authority, and purity. And so what it looks like is you have liberals that are on really more of a two-channel morality, and conservatives, if you look at conservatives, very conservative over here, just to compare the two extremes of the scale, very conservative. People who say they're very conservative tend to have nearly equal weighting, a little bit more weighting here for this purity item than others, but they tend to be equal weighting pretty much for all of these pillars of morality. So conservatives are said to have, operate on more of a 5-pillar morality. And so there's these fundamental differences that some researchers have found with respect to political biases. And they would argue that that is ultimately what drives our political biases, is that we have developed attitudes towards these core issues, these moral issues of how not doing harm and being fair, and how much loyalty should you have to your family, to your clan, to your tribe, to your your race, etc. How much should you respect authority, and this issue of purity. That seems to what drives ultimately your voting behavior. When you're an adult, these things are developing as you're a child and adolescent, and then as an adult, this seems to do a pretty good job predicting. And so this, you can really get into the weeds here on how, and a lot of fine-grained detail, I guess, very fine-grained assessment of how one would define then people's respective values or scores that they would get on measures of harmness, harm, fairness, in-group authority, purity, these 5 different pillars of morality. And so this, just to give you an example of the kind of questions that are used to assess this. So can you guys see that quiz that popped up there? Can you give me a thumbs up, somebody that thinks, yeah. So this is directly from the the morality quiz. I think it's called Foundations of Morality quiz. And here, look at this first question. I would call some acts wrong on the grounds that they are unnatural. Well, okay, how would you feel about that? Would you strongly disagree with that? Would you strongly agree with that? Or are you somewhere in the middle? And look at this next one. Chastity is an important and valuable virtue. Where would you rank on that? So these are two items that are tapping in to the underlying dimension known as purity. How concerned people are about their notions of things being pure in the world, about not doing things that are unclean. This is a pillar that people from multiple different cultural backgrounds, they tend to be concerned with this in varying degrees. And so there's that. This one, people should be loyal to their families even when they have done something wrong. Okay, you're going to find that in non-Western cultures, people are much more likely to say yes to that than in Western cultures that are more informally legal based. It is better to do good than to do bad. That's a little bit on the nose kind of item. That may be an item that they use to check to see if the people are taking the survey seriously or not, because it's really kind of on the nose, like it's obvious. But the next one, respect for authority is something that all children need to learn. Yeah. People who are more conservative tend to agree more strongly with that than people who are more liberal, where they accept more of a kind of a Rousseauian idea of human nature, even though they don't maybe know that exactly. So this next one, compassion for those who are suffering is the most crucial virtue. Okay, well, I would say that might be debatable, but that's me. And so how would you feel on that? That's about the note not do any harm principle that or one of these pillars of morality. This one, it is more important to be a team player than to express oneself. So that's in-group loyalty, that the team is higher than you. And so again, that's something that actually, people obviously play team sports in the West. Western people tend to think of themselves as being actually more important, not as much as part of a team as people that are more used to kind of tribal and partisan type thinking in their countries. I am proud of my country's history, and so this is another in-group loyalty type question. I think it's morally wrong that rich children inherit a lot of money while poor children inherit nothing. Okay, so people who are more liberal are going to agree more strongly with that, and that's this issue of being equitable, being fair, that liberals tend to rank higher on. So these are all different, pretty simple Likert type scale items that are all measuring various dimensions of this, or indicators of these would be the indicators, but they're all measuring then in turn these dimensions, what they call these 5 pillars of morality. Okay. These are the specific indicators, and they all feed into these various dimensions. You can it's once you know what the pillars already are, it becomes kind of transparent what each one of these indicators is supposed to be informing, or supposed to be contributing to, like which pillars it's supposed to be helping to measure. You think of the indicators as being a helping measure, trying to help to measure these bigger underlying dimensions that all are related to this major concept called political orientation. So yeah, that's that. And there's something else that I want to show you as well that's directly related to this. Get back to my screen just a moment. Sorry. Okay. Just a moment, folks. Moodle's acting a little bit funny. Oh, okay. Okay, so also, yeah, when I completed this thing, I completed it a while ago, and I completed it just recently. So here are, can you see those results? There's a little bar histogram chart. Somebody give me a thumbs up if they can see that. Yeah, okay. So This, well, this doesn't actually is not showing my results, but it shows, why is that zeroed out? That's strange. I wonder if, hmm, that's weird. Well, it's showing partial results. It's showing the average scores for people who are liberal. Red, people who are liberal is blue, and people who are conservative, which is red, on these various dimensions of harm, fairness, loyalty, authority, and purity. And so, you would see if you took this? You would see yourself in green, and where you would compare to other people who self-identify as liberal versus conservative on these various dimensions of morality. All right, so there's that, and there's also on the Moodle page there is a place where you can complete that survey and you can find out where you stand, where you rank. And so, yeah, for your exercise, what did you come up with ways other than just political party affiliation that you would identify people's political orientation? That what would you say? Who would like to volunteer something? I'll take a minute to think of a couple things that you would probably want to know if you want to pinpoint someone's more liberal or more conservative. This is something that you could you could ask about their shopping habits. there's things that people do that some people are more liberal versus more conservative will do. Yeah, Christine. Sorry, go ahead then. Yeah, yeah.
I was gonna say maybe where they live, like north versus south areas, or maybe like rural versus urban areas.
Yeah, that would be at a level of unit analysis. So you're not the person level, you're at like a county level maybe, or even at the state level. So people in the South, yeah, there's a higher degree of Republican or conservative voters down there, and also, yeah, if you're living in a rural area versus an urban area, rural areas more likely to have more conservative, more Republican voters, whereas cities more likely to have more liberal and more Democrat voters. So yeah, there's that basic divide there that we know about just at the geographical level. We can kind of say something about the general tendency of the population in that area by knowing their geographical location. Yeah. So what was it, Mike? Was that you or was that?
Yeah.
Okay, Mike, and then Emily. Yeah.
I was going to say you could look at feelings toward just kind of like hot topic issues in government. So like maybe see people's different views on abortion, gun control, like the main points where you see liberals and conservatives really differ.
Yeah, so all the hot button issues, exactly. So yeah, guns, abortion, those kind of issues would give you a good sense of, or a good indication of where people are leaning in relationship to other people on this underlying dimension of conservatism and liberalism, right? Because these are not things like the air temperature that we're measuring. These are mental states that involve all kinds of assumptions about people and your beliefs and your more how you're raised. And so this is a very squishy thing that you're tapping into people's feelings on particular issues to try to get a sense of this underlying thing where all these things kind of tend to have to do a balancing act in people's heads. And so where they stand on hot button issues is a good way to tap into their overall political affiliation orientation. Yeah, Emily?
Well, mine's kind of like piggybacking off Mike, but I was going to say, can you ask more direct questions like, do you own a gun in your household? And then like, how likely are you to purchase a gun? And you could do, very unlikely or extremely likely and do things like that to see where they stand on issues like gun control and things like that.
Yeah, I mean, that would be, I would suggest that would be an independent measure of guns from someone's political attitudes, because if you have something that's asking more specific questions about gun ownership and things like that, as opposed to favoritism towards the NRA, you might find that you would be able to say, okay, who is among Democrats who's more likely to own guns versus being in favor of changing gun laws, because you have a lot of people who own guns, but they are in favor of reforms to the interpretation of the Second Amendment. So that's a good example of kind of an independent control, like you would be able to assess independent of people's political attitudes, whether or not they just have a gun in the house. And so those are very important kind of control variables to have in any analysis. The sort of things that variables that you don't account for are usually things that would help to explain what's going on in the study if you did account for them. So that's the kind of thing you want to account for in addition to kind of direct political attitudes. What else do people have in mind? Okay, Jared, and then Rebecca. Okay, yeah.
I'm not sure if someone already said this, but you can look at like the type of news station someone watches, because I know like certain news stations lean certain ways. So like during the election, if you're like a Republican or a Democrat, you'll watch different news stations because each one will favor a different president.
Yeah, absolutely. So the Fox News viewer is going to be more likely to favor Republicans generally, and the MSNBC news viewer is more likely to be favoring Democrats. So their television viewing habits would serve to reinforce what they already believe, and that's part of the problem in modern media today, that because you can select what media you get, there's so much choice that people can kind of conclude themselves in their own political bubbles and only consume the things that reinforce what they already agree with, and that's a problem. But yeah, that's something that certainly is a good indicator of somebody's political biases. What is MSNBC or is it Fox? Yeah. Rebecca?
I was gonna say the same thing about news stations, like
Okay, yeah.
watch a certain one and all that.
Yeah, so the news stations is going to be a good indicator of someone's general tendency towards probably conservative or liberal policies, probably maybe across the board. That'd be an interesting thing to know is, how much you watch Fox. Is that going to predict really well things that we tend to associate conservatives agreeing with to a greater degree, like with guns and whatever. Anything else that we had? Anybody else want to take a shot at this? That something else that you haven't heard yet that you think would probably be able to correctly identify? So we say correctly identify or discriminate among the population reliably and validly. Who are people who are conservative, self-identifying, people who are self-identifying more liberal, and then everybody in between. So it's very important that we're able to get everybody in between the bell curve of the distribution. You got extreme hard leftists and extreme hard right wingers, but most people in the United States really are somewhere in the middle. And sometimes things that very few issues divide us seriously. A lot of things we're in the middle on, but there has been this bifurcation in the last more than 20 years of people kind of the left and the right, the political spectrums dividing apart in the country. So anything else that people want to say about this measuring political orientation and how to do it with these various indicators that speak to these dimensions that are these supposed to give us a good comprehensive global assessment of something as big and squishy as a political orientation. That's what we try to do anyway in the social science world, is to try to put some numbers, as kind of squishy as it is, to these concepts. Okay, was there anything else I wanted to, let's see, point out on this? Well, yeah, so what I'd like you guys to do, if you haven't done this already, it is something that's somewhat interesting. If you take this survey, you can see it where you're going to line up with respect to other people who've also taken the survey, and people who are on the liberal side of the spectrum versus people on the conservative side of the spectrum. And that's entertaining, if anything, but it's also might be revealing about yourself. Here is a video that I posted that's Jonathan Haidt, one of the lead researchers on this, talking about this at a TED Talk. And so you can go into that a little bit further, listen to the kind of theoretical underpinnings of why they did what they did and how they went about going about doing it. So there's all of that. Okay. So what we're getting into next in this class, and we'll break, I think, just a little bit early, but I want to get into some of this just so we are not getting behind. Chapter 6 talks about indexes and scales, and while go ahead and read that, we'll come back to that concept one more time when we're getting into SPSS, because we will start using AdHealth, a scale or an index of some sort to measure some underlying concept. Not going to be as complicated as what you don't have to come up with, 30 different items to measure these different, 5 different dimensions or whatever. You don't have to do anything that complicated, but we'll come back to that chapter in greater detail in a couple weeks and talk about using the AdHealth data that's posted, that will be on Moodle that you can access with SPSS and make your own index or scale. What I'd like to get into here for a little bit is the chapter 7, the following one, that talks about sampling and talks a little bit about the statistical theory behind inferential statistics and, well, the sampling method that goes into that. So this is lecture 6. The other thing that we'll get into here in just a second, but the other thing that I will want to point out is that all the SPSS videos that I've been posting in my other class that just deals with SPSS and statistical analyses, I've posted most of those here on this page as well for graduate students in particular, who we're gonna be getting into SPSS here in a couple weeks, but graduate students will have to do a paper involving some analyses. And so especially for people who have never used SPSS before, or have not used it in a really long time, you can go through and just watch the videos I did with the other class and get an overview of real basic stuff with SPSS and how to just do some descriptive stats. And then we'll get into some upper level stuff later on. But yeah, if you've never used SPSS before and you're in the graduate class and you would like just to take a look at this real basic data input and descriptive stats, then watch these videos. All right. So let me get into this. Next chapter, if I have it up here. Okay. All right, so when we are doing statistics, we have this sample. We have the AdHealth sample, for example, in this class. That's a sample that's supposed to be nationally representative of kids in high school in the mid-90s. What we're ultimately interested, though, is not really the numbers that are written into the spreadsheet in SPSS. We're interested in the population parameters that those numbers are supposed to give us a rough idea of. It is this elusive true score, the true mean, the true percent of people that have done X is what we're really interested in. We cannot measure it directly. We measure it indirectly via taking large samples of the population to generate statistics that in turn serve as an estimate of the population parameters. And so with the case of the statistic X bar for the mean, that is an estimate of the population parameter called mu, a little like mu, U-shaped Latin letter. It's called mu. And so that is what pretty much all inferential statistics are about. They're about providing various estimates using observed data of population parameters which are not directly observed, that are just out. We assume that they can be measured, that they're out there. We're just not trying to measure invisible dragons, that they're really out there, and that statistics are to estimate what they are. So there's always then error in trying to estimate this thing that is basically thin air that you can't really do directly. But this can be minimized if you have large samples. And so this, in a lot of quantitative analyses. That's why, like, the most important thing over and above how fancy your regression models are and all of that, how fancy your theory is, it is how many observations do you have in your data set. That over and above anything else will improve the inferential power of the statements that you make. If you're making broad sweeping statements about people from different groups and backgrounds and things like that, yeah, you need to have a very large sample size to make anything that that would be believable beyond political correctness. Again, just that would be believable on a basic statistical level. So these samples are said to be theoretically drawn from an infinite pool of other samples. It's called the sampling distribution. And so it is logically impossible, therefore, to take a large sample of the population, because the population will always have infinity left over. And so populations are said to be infinite. Well, how can that be with people? You know, at any given time, there's only so many people, but that's only a sampling of those people those particular times. You're not considering all the people that are long dead and people that are not yet born. And so if you think about it like that, then it does start to approach infinity, as they say, of like the number of people that really could have been in your sample, but just the fact you're in this place, this time, they weren't in your sample. And so that's why populations, any kind of population, you can think of it like that as being infinite. And so that's the assumption for sampling. And so there's always, going to be error. So that's called the standard error. That is a statistic that's associated with any estimation of the average. So you have in descriptive stats, there is the standard deviation, and so that is a statistic that is showing the error, the average difference from the average. And so when you have then inferential statistics, you have estimates of the standard error, which is the same thing in concept. It's just the average difference from the beta estimate, the estimate of R, whatever statistic you're calculating. You always have some sort of standard error, and that is minimized though by the bigger the sample size you have. The error shrinks in proportion to the size of the sample. The error shrinks in proportion to the size of the sample. So that's just like the law of stats. And these are all basically trying to estimate some population mean, so the equivalent in the population of the X bar is mu. And so you're trying to get a estimate of that. And the population equivalent parameter for R and correlation is rho. They all have a Latin name. All the population parameters have a Latin name. And then you have just you use regular English to describe usually the letter like R, and well, there's beta or B for regression parameters, but they all have some sort of population parameter name, usually Latin name, that's associated with the thing that you're really trying to figure out based on your observed data. And then there's the central limit theorem, and that's assuming that the sampling distribution, the population parameters within them, even though each individual measure in your sample is not going to fall into a bell curve, that the sampling distribution will always fall into a bell curve. That means that if you take 100 samples of 100 people and you measure their average heights, the averages could be plotted in a frequency distribution, and those averages themselves would start forming a bell curve. So the average height out of all the samples, they would be very similar to one another, and they would pile up in the middle. And then you'd have some samples that we would have weirdly high averages, and some samples that would have weirdly low averages. And you would get in this distribution of this infinite sample pool, you would get something approaching a bell curve. And so with just 10 samples, you probably wouldn't. But as the sample size approaches infinity, it's going to start forming a bell curve. So that's why there's a lot of stress or emphasis usually in intro-stats class on things like the z-scores and the estimating the probability of something happening, because it's all based around this idea of central limit theorem and the way that the sampling distribution is distributed if you graph it. So okay, so that's some of the statistical underlying assumptions behind sampling. And so a sample is a subset of a larger population to describe various aspects of that population. So one of the survey samples I participated in was the Toledo Adolescent Relationship Study that we surveyed 1,316 youths and parents from the Toledo, Ohio area. I went into probably about 300 of those houses over a period of about 3 or 4 years, and just came in and handed people laptops, and and then I usually read something and they filled it out, and that was just collecting the data. But that was part of this. Now I think they have 5 waves of this thing that comes out of Bowling Green State University, and then the sample is there to say something about youths and parents in general about this larger population. So not really supposed to be just about Toledo, Ohio, but you could say inferentially in people who live in places like Toledo, Ohio, this is what you can expect of the youths and parents and their behaviors and their attitudes and how they link up, how they relate to one another. And so that's example of a sample. So you have this population that you're sampling from. Clearly, the population of Toledo, Ohio is more than 1,300 people. If you're trying to estimate population parameters, you're going to try to get a representative sample of the population. So you want to try to get a representative sample of the population if you want to get a good estimate of the population parameters. And so you might have the goal here, for example, of the population who, estimating the population of people who approve or disapprove of a new handgun possession law. And so if you have a population of 20,000 voters in city X, we represent a simple random sample of maybe 1,000 potential voters. And so long as you have a systematic way of going about doing that, that 1,000 voters potentially could stand in to understand the population parameters of a population of 20,000. Okay, so the big difference between the size of the population and the sample is not a thing that you need to worry yourself with, because you can never take a large proportion of a population that is theoretically infinite. And so it's not about the proportion of population that you sampled, it's always about the population size itself. The actual N equals X, whatever in your data set. How many observations do you have? And so it's not proportion of sample. That's not a thing that that statisticians will point out. Only, I mean, there are some cases, not to get into the weeds on it, but there are cases where you would want to think carefully about that if you really are getting close to the true population size. But that's, that usually doesn't happen. So when you're doing this, you want to have what's called a sampling frame in mind when you're going to collect data. And so where exactly are you going to get this data from? What's your data source? So it could be some school rosters, could be telephone directories, address directories. Can we think about any problems that we might have just right off the bat in some of these ways? I would say you would get a sample, a random representative sample of some population X of 1,000 potential voters. Any things that we're overlooking here? Any problems people could identify right away with any of these methods? Just the ones that are listed here. Just trying to get a random sample of names of likely voters, potential voters. So people have to be at least 18, obviously. So but besides that, I mean, one thing that telephone directories, people having cell phones now more almost ubiquitously, and having fewer people having landlines, telephone directories are far less reliable than what they used to. Anything other than that? Because that one is, it's a problem now. This is why you get free stuff on the internet usually comes to exchange of a cell phone number, because they sell your data, and then people then have your number, and then they can, because you can't get it so easy on telephone directories anymore, because those things are not reliable in terms of a big sample of population. But people who have don't have permanent address is an issue. People limited number of maybe 18-year-olds. Of course, it's limited to people who are probably seniors in high school, but among them, some of the people may have dropped out, but they're still likely voters, and so that can be a limitation there. So you got some selective observations that may be based on the limitations of your sampling frame. If you have a sort of variable of interest, for example, a dichotomous binomial variable, that you have two possible responses that you can just say approve or disapprove of this new gun law. Theoretically about the same as average proportion who agree and found sample of 10 equals 100, yet the error would be very much greater. So if you did, the sampling error for 1,000 people in a population of 20,000 is going to be proportionally about the same, but the error is going to be a lot greater if you have only a sample of 100, even though you're sampling the same proportion. Does that make sense? You always want to have this. In fact, you always want to have the bigger the N, the better. It's not about the proportion of the sample of your population, because again, it's this thing that the populations are always supposed to be. They're theoretically they're infinite. So anyway, I mean, this again, just remind yourself again and again and again. It's not about proportion of the population sampled. It's about the sample size itself. It's always about the sample size itself in most all sampling situations. So the representative thing, that's what's really key here. In addition to having just a big sample, you want to have a sample that is representative. Okay, and so one way to make sure that you really are having a large random representative draw from the population is called stratification or stratified sampling. Ensures representativeness of the target population by sampling from groups within that population. So you sample randomly from a population of college students, sampled based on groups of freshmen, sophomores, juniors, and seniors. So grade level or class level these are strata. It's a different strata. So a freshman is a strata, sophomore is a strata, junior is a strata, senior is a strata. So you random sample within that strata. Stratification may also happen on gender, GPA, race, etc. So you have a large, hopefully large random draw from within a group category. And so by creating these homogeneous subsets, that in theory minimizes error in the sample statistics estimating the population parameters. That's the logic behind it anyway, because you're sampling within population that is all similar in some key respect that you think is important ultimately for your sampling strategy. And so, yeah, with this, this comes along the idea of meeting population quotas with these stratified samples. So 10% of the college population are male seniors. A sample of 1,000 should have 100 male seniors in it. So you would try to set these quotas when you're doing the stratified sampling. That's one example. There is also this strategy called cluster sampling. And so when you are doing a cluster sample, this is an exhaustive list of a population is not often available. You can't have a completely exhaustive list of everybody living in a particular area. So you sample from a cluster or grouping of various population elements. So you don't have an exhaustive list of everyone in a city, but the census blocks may be randomly selected from a list of people within these blocks may also be selected. And so you have a way of going about getting people from different social class levels, for instance, by looking at census blocks as one cluster, level one cluster, and then you randomly select some census blocks. And then you have these census blocks on a level two cluster are the people within these census blocks that are unique in ways that probably relate to levels of income and unemployment. And then you randomly sample from those respective clusters. Okay, so this is called the multi-stage cluster sampling. And so it's just like a group within a group. So you have a random selection of groups, and then within those group clusters, you grab a random selection. All right, so that's The sampling error, though, can occur at both stages. So you can, not get a good representative sample of a large population based on the census blocks you gathered, and the people within those census blocks may, for whatever reason be a weird, not representative sampling of the people that otherwise that also live in those census blocks. But all these things, when combined together with a large sample, help to minimize the standard error, the error in the estimate of the population parameters. And so these things can also be used in conjunction with one another, and they often are in large scale studies. So census blocks may be stratified by percent more minority or unemployed, also in addition to having them in this cluster structure. Okay, so I think I'll probably want to just stop there. The next part, we're going to talk about non-probability sampling and some problems that result from doing it in a non-scientific way, how you can make predictions that are just totally wrong. So we'll get into that stuff on Tuesday. So we should be back on campus on Tuesday for people who are joining us on campus. And unless you hear from me otherwise, it's at room 206 in the Science Center. All right, folks, are there any questions or comments that people would like to provide before we jump off here and say goodbye? Have a good weekend. No? Okay, well, have a good weekend. I'll see you all on Tuesday through Zoom or either in the class, okay? All righty, take care.